actual code, not just in FastCore, but FastAI notebooks. So that's what he and I agreed to do. So this week, what I'll spend the rest of the time we have doing is kind of going through the notebook of FastCore called Basics. And this notebook actually, Jeremy, has shifted some of the code around since when we started on going through FastCore. So I'll start sharing the screen and take you through that. So that's kind of the plan. So we'll go through just the code this week, and then next week, Raquel will take most of the take up most of the class, and will explain the usage, or at least dig up examples of usage from FastAI actual code. Let me know if you guys can see my notebook.
Yes, it's visible, brother.
Yeah, we can see it.
Okay, sounds good. Then, so this is the basics notebook, as I was saying. And we kind of started to look at it last week, and there were some questions. So I did a quick example borrowing from Raquel. So he starts off by defining a namespace, and then he does a namespace is just something where you have names that you can assign value to in Python. Then he defines this if none function, and basically it's a fairly simple function. Essentially, it says what the one line of code below that you see. If A is none, it returns B, otherwise returns A. That's so if this is none, you get this value, otherwise you get the A value itself. The difference between using it as a function versus having this line of code itself is something that he explains here. And I think we had some discussions with David and Raquel last week of why is he giving us a warning that be careful. If you don't want B to be evaluated, then you better just use the one-liner actual expression rather than the function. And we will see that in a minute. So he does the testing of the if none function, and it's fairly simple. If none, and this is none, therefore you will get the value B. If the value A is not none, as you see in the second test, then it returns that value itself. If it is none, it returns B. If it's not none, it returns A. So that's as we would expect. But look at actually, if you just write out the code, and let's say we want to do this. So what we are saying is return 10 divided by 0 if 10 is none, which it is not. So it's as if we have coded this line of code here. So 10 divided by 0 if 10 is none, else 10. Now, in this case, even though this expression is something that it ought to complain about if it is evaluated, if written in a single line like this, it doesn't evaluate 10 divided by 0 if this condition is not none. So you are safe in that it will not complain about 10 by 0 being a problem or an issue, 10 divided by 0 that is. And it will not complain about a divide by 0 error. It will just give you the 10 as you would expect. Now, if for the other hand, you did if none 10 divided by 0, you would this is the warning that is giving us, that if B is an expression that you do not want evaluated, then don't use the function. Use the one-line expression like that. If on the other hand, this function is okay to be evaluated, then use the function. So that's what I have coded, because if I were to run this, it will complain about a zero division error. Any questions?
Yeah.
Okay.
So why on the cell above, why it didn't give complaint division by 0 on the cell 86?
Because it never evaluates this depending on the depending on the condition. It never evaluates this. In this case, both, and this is one of the discussions we had earlier, I think Python evaluates both of these, or requires, or does the evaluation of A and B when you pass it in as parameters in a function. And
So
since it evaluates this, it complains about it. But in this case, you write it as an expression, then if 10 is none and 10 is not none, so it doesn't even look at this part. It does not touch this part. It doesn't evaluate this part. Here, it evaluates this.
both.
That's the difference.
Okay, makes sense. Thank you.
But that's kind of interesting. So now we learned that, if you pass some things as parameters, that they get evaluated. And, so that's an issue. In this case it is. Sorry, somebody had a comment.
Yeah, but I think this should be something unique to Jupyter notebooks, yeah, to all this REPL environment. Do you think this will also be happening in them?
I haven't checked, but I would imagine that, yeah, I don't know that this is unique to, because where it gets evaluated is when you pass it in as a function. So it's a good question. I'll run it in like a VS Code.
VS Code,
check.
yeah.
Yeah, I have VS Code, so if I'll run it later and see whether, my guess is even VS Code would complain. It would complain if I code it as a function. It will not complain if it's a one word. This I know for a fact. It will not complain regardless of where it is, Jupyter Notebook or wherever else. The question is, does it complain when it's given as a function? I think it's a property of Python function. So I don't think it's a property of Jupyter Notebooks, but I could be wrong. We can check that by running it on VS Code.
Okay, just a quick question. Like, if we should print the output of cell 86, that is the one that we just run without it. If we should put it in a print, do you think it will run? Can you do that, please?
If I did print this, you're saying do this?
Yeah.
Yeah. I don't think it will change, because print is just a call. Now print is a function, so that function calls. Oh, but here it might complain.
Yeah. So that's also, I just wanted to check.
It doesn't, because I think inside of here, this expression is evaluated, and in this expression, because it takes place in stages, right? It just runs this expression, and we have already seen this expression works without print. It returns 10. So print then prints whatever this expression returns.
Interesting.
Right? Because print is just a call to a function, and the function is, we already saw the line of code before that. Like, let me do one more cell here. Oh, come on. There we go. At least we already saw this works, right? That doesn't complain. So this line, this expression will return 10 to print, and print will print 10. So that works. But in this case, if none, 10, 10 divided by 0, here the problem is it evaluates this, or, it evaluates both A and B when it runs. And that's what he's warning you about. It'll evaluate both nice. A and
Cool, thanks.
And I'll also double check your actual question, which is, I'll run it on VS Code and check whether it complains. I would imagine.
Yeah, I don't think I think it will still be the same behavior. That's just why I wanted to check with the prints, because yeah, But yeah, you can still check, but I guess it will be the same behavior.
Yeah, I don't think it will change the stuff. So don't think that will work. Okay, so now moving on. The next thing he does is something, again, it's interesting. It says maybe ATRA. And what this is essentially kind of a little bit of a strange construct, but it's a simple enough construct, which says, give me the attribute if the attribute exists, otherwise give me the object. So if the attribute doesn't exist, it just returns the object. So if the attribute, I should say more thoroughly, that if the attribute doesn't exist on the object, it returns the object. If it exists, then it returns the attribute. Because here it says get attra the O of attra, which means it gets the attribute of O, and the default value it returns is O, which is the object itself. Okay, and that's where I said that, what was more interesting to a certain extent is where these things prove to be useful, and Rekel will look at those things and kind of show us next week where these things are put to use in FastAI code. So you can see class my object, my attribute is foo. So when you test equality of maybe attribute, my object, my attribute, since my attribute exists, you expect the result to be foo. However, if you check, I don't know, some other attribute, then that doesn't exist on my object. So my object is returned. Right? Any questions? Okay, the next one is a little more interesting, which subsequently puts to good use in one of the bigger functions in this particular module, and that is a function that he defines called basic wrapper. So what basic wrapper does is, let's say fields, and fields is just a bunch of let's think of them as attributes of a function or a class or something. Then if it's a string, which attributes typically are, then you would say fields, he just splits the fields and captures all of the uh, captures entire strings in the fields while separating them with comma, and then sticks them in a list. If fields is none, then obviously you're just going to get an empty fields thing. And then he defines a function called underscore f, where he combines, and as you can see here in an f string, he just says, oh, what I'm going to do is either stick in the attribute for each value in the fields, which means for each attribute name in the fields, either I return the name or I return the wrapper, which is, if you recall in Python, the dunder wrapper is the representation that you choose to code for a particular object. So either you get the name or you get the representation of that attribute. Stick all of them separated by commas in sig, and then stick the name of the class in front, and then return the sig. So, and then return the function that you have defined itself. Okay, so that's what he defines basic wrapper to be. So it, in a way, is a wrapper of all of the attributes and the function name of a function, or all of the attributes of an object and the object name, right? So that's kind of what he's trying to create. So he explains that here. Look up a user supplied list of attributes of an object and generate a string with the name of each attribute and its corresponding value. And the form of the string is key equals value. That's what you see here, key equals value, where key is the name of the attribute and value the value of the attribute. For each value, attempt to use the dunder name, and otherwise fall back to using the values dunder wrapper when constructing the string. So all this is a lot of theory or a lot of words. It obviously makes it a lot easier if we look at an example. for which let's
Sorry, please, but what's this exclamation mark R? I don't really get what it's. What's it?
Yeah, typically this bang R tendo is when it's used for, hey, give me the rep. It's like saying, give me the dunder wrapper of everything before
Wow,
that has given before.
like
I've
a
seen
shortcut.
this used. Sorry.
Is it like a shortcut?
Yes.
But does it like does it do the same thing with like writing REPR, like stating it, calling the function itself?
You can try.
Yeah.
I haven't tried it myself. I've seen this used so often that I use it myself. The bang R. See, the bang R where I have often used it is now I don't know. Now I don't remember in which direction, but you can play with it to figure that out yourself. But see, sometimes you want the quotes in the string, and sometimes you don't. When you have a string, sometimes you want the quotes around the string and sometimes you don't. And I think, if I recall, and I could be incorrect in exactly the opposite way, but if I recall, the bangar actually keeps the quotes typically. But in general, the bangar, which means the exclamation point R, is just saying, return to me the wrapper of that guy.
Wow, neat.
Yeah. I have, in fact, I never bothered to. You can check where it says in Python documentation that it does that. But I saw people use it, and then I saw what it did, and then I've started using it.
Cool. Thanks.
So now let's see this, because you'll see the usage and it'll become a lot clearer. So you see, oops, I went too far down. Go up a little more. So let's define some class, attribute A, B, and then see the dunder wrapper of this class is just pointing to and replacing it with basic wrapper of AB. Okay, and this string A and B is what FLDS is, right? Because if you recall, remember this code, fields is none here, and fields is actually a string. Then you split it with a comma, so it splits it with A and B, right? And then we'll come to this class in a bit, but let's just first do, and then you define an instance of the class. SC is some class, and then see what happens when you do a wrapper of SC. When you do a wrapper of SC, you get the name of the class, because that's self.dunder class.dunder name, some class, and then you get an open bracket because you get this guy joined by commas, right? And the open bracket here comes from that little orange guy there, right? And then the rest is the sig. So what is sig? Sig is O, and we have split it, and O in this case is A and value is 1. So you get A equal 1, and then O for the next O in fields is B equals underscore foo. And the thing, as I was saying to you, Tendo, is the bangar keeps the string of foo intact, meaning it still keeps this string without getting rid of it. And you'll see if you don't have the bangar, it doesn't give you that. And that entire thing is what you get as a result of making the wrapper of this class equal to the basic wrapper of its two attributes, right? And then he shows that, let's say you define another class and you make, let me just move it a little bit down. Let's see whether it does that. There. So then if you define another class, and then an attribute of the class is actually this class, because you've given it some class, and then another attribute which is bar, and then you just do dunder wrapper is basic wrapper, and the attributes here are obviously C and D, right? And so AC is another or AC is an instance of another class. And when you do wrapper of AC, then you get another class. And what is C? C is some class, but some class with its attributes, right? So some class with A equals 1 and B equals 2. So that's why you see that here. And then D, on the other hand, is just bar. So you get D equal bar. So by having this guy defined this way, you can kind of get all the attributes that and get a clean wrapper of the class definitions and its attributes. Okay. Now here is another.
So, can I ask you a question?
Sure.
It's just a note question. So wrapper of any class, in a sense, this is going to be in when he defined further on. So is this the function he's defining to represent the attribute within a class? So if I want to access the attribute of a class, I will do the wrapper SC.
No,
What's the usage?
No. Wrapper in general, the wrapper of any class or an object, typically let's stick with the class. When I say class, though, assume that it is generic and it represents object, but most often it's a class. So I'll use the word class, but it's true or generically of objects. So in this case, I'll just refer to class. So in the wrapper, when you say wrapper of something, then the wrapper of a class object calls the dunder wrapper definition within a class. Okay. So this wrapper of SC is actually calling this dunder wrapper, but dunder wrapper has been made equal to basic wrapper. You see what he has done? So by saying wrapper of this, you end up calling that guy. And by saying wrapper of that, you end up calling the basic wrapper with the two attributes C and D.
Okay.
Right? So this is just two and generically in Python, dunder wrapper or dunder string is coded to represent. In fact, wrapper is just short form of represent, right? I mean, basically, that's it. It's not exactly that, but I'm just saying, to me, mentally, I remember it as, oh, I just want a representation of what this object is. So, and the other thing, I think Raquel mentioned it last time as well, is you can code string and wrapper. And again, I always forget which is which, but one of them is supposed to be exactly what the code does, and the other is a human readable form of what you want the object to be. Okay. But I forget which one is which between wrapper and string. String, for example, calls dunder string, and wrapper calls dunder wrapper of a class. But what is important, even more important to remember, is if you want to choose between wrapper and string to code, it's better to code wrapper, because if string is called and dunder string doesn't exist, it will default to calling dunder wrapper. But the vice versa is not true.
So can you repeat that last?
Sure. If you wanted to code either a wrapper or a string, because ultimately, if you did not code and have these things in your definition and you just called the class, it will show object blah 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 blah, right? It will not give a nice representation of what the class is. Do you like, if you define the I can do that here, but it'll screw this up. So if you just define any old class, like even some class, and then you didn't have a wrapper, and you called the class, you called an instance, and then you wanted to print out the class, it will not print such a decent explanation or decent representation of the class. It'll just say my object, blah, 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 class, blah, 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 things like that, right? It will not give this neat representation. Forget about even identifying the attributes of the class. It will not even give the class name and stuff. It will just say my object so and stuff. That's why you code wrapper and string. But the thing I was saying before is the fact that if you had a choice, if you could only code one thing, and the first thing I would say is if you search for, the difference between a wrapper and a string in a class definition, it will explain to you that one of them, and I can't remember which one of the two.
That should, the string is like the human readable form, while wrapper is like computers.
Okay, yeah. So as Tendo says, string is the, you want in a dunder string, the definition of the class coded in such a way that a human can read and understand what the class does. On the other hand, you want in dunder wrapper the code to reflect precisely what the class does, like a code for a developer. So it's like an API, or, oh, if I need to use this class, this is precisely what the class does. The string, on the other hand, is a human readable form of the class. Okay. Now, having said that, if you were to code only one thing in the class, it should be a wrapper, because if you don't code a dunder string, it's okay. When you call string of a class, it will use the dunder wrapper and return what is coded there.
Okay.
So if you don't code a string but code a wrapper, that's good enough. If on the other hand, you only coded string and you called a wrapper on it, it will complain that it will say, I don't have a representation for this class. But if you code a wrapper and you called a string or you called a wrapper, it will return what is in the wrapper.
Yeah. Okay. And when we say coding a wrapper, so that basic wrapper is like, that's depends on you, whatever you want to.
Yeah, in fact, here he has done it and pointed to basic wrapper, but that is not typically how it's coded. Typically, you would do it like a dunder init. You would do this, but because he wants to use basic wrapper in multiple places, typically you would do this. You would do def, just like dunder init. And then code. You see what I'm saying?
Yeah, makes sense. Yeah, thanks.
That's how you would code within a class what you want the wrapper to be. But in this case, he just points the dunder wrapper to basic wrapper.
Right. Yeah.
Because he has already coded this function which he wants to repeatedly use.
Yeah. So in a sense, whenever you want to know anything about a class, all you do is just wrapper and then the object of that class, and then you'll get the definition of a class itself.
Yes, if it exists.
If it exists, yeah. Yeah.
If the guy coding the class has done a dunder wrapper.
Yeah. Cool.
Okay. So this is array is actually, he just checks whether you have an attribute dunder array or it's a data frame. If it's a data frame, it's going to have an iLog. If it's an array, it will have an attribute of dunder array. So it just says return true if this X is either an array or a data frame. So in FastAI, if he's checking is array, it means either it's an array or it's a data frame. Okay, and you can see he's testing it. This test should be obvious, meaning you define a numpy array of 1. Is array, obviously numpy array will have a dunder array attribute. So that's true. Is array of a list of one. This does not have a dunder array, nor is it a data frame. Therefore, it's false. Right now, we kind of, sorry. Kind of spend, I think last time for some reason, we complicated and good to refresh our memory of what it does. Oh, that's not good. Okay. Basically, listify. You and by the way, Jamie has listify, tuplify, certify. It has a bunch of these things which all do similar stuff, but listify does a little more things than. And once you understand one of these, then you can kind of interpolate to the others. So listify. So let's uh,
Hi, Srinivas. Can't hear you.
hi, can you hear me?
Yeah, now I can. Yeah.
Yeah,
Yeah, we
sorry,
can.
just a heads up that it said my internet connection is unstable and dropped me, which is really weird. But just in case it happens again, just be aware I'll try and rejoin. Are you still able to see my screen or do I need to share again?
No, share again, please.
Okay.
Yeah, you can see now.
Okay. So I was saying that Listify, Tuplify, he has a bunch of these. Basically, if you look at it, what he's saying is if you have values in REST, combine them to be a tuple along with the object O, which you convert to a single entry tuple, which is typically specified as O comma within these brackets. Add rest to it, which means append rest. So all of these values in rest get combined with the value that you provide, and you create that, and that's what is in O. If you say useless, then make O, that means this object that you have given it, make it a list. And actually, you already have added the rest to O, and that's what you convert into a list. If O is none, then you make res to be an empty list. If it's already a list, then you just make res equal to O. If it is a string or if it's an array, then, and here's where the behavior is different if you just did a list of something versus you listified something. And I'll explain that in a minute. When we look at examples, it'll become clearer. Here, you take the entire string and you take the entire array and you stick it into a list. Okay. And if it's an iterator, make a list of all the iterables within it. And if none of that is the case, then just stick the object O inside the list. Then after you have done all this, you have a res, which will be a list. Now, now let's begin to look at match. If there is a value in match, and if match is a collection, just in match, stick in the length of the collection. So all you're extracting from match, if it is a collection, is its length. And if the length of what you end up with as a result of all this processing is 1, then, and your match is some value, then broadcast result to match. And we'll see what that means when we use the examples. It'll become clearer. However, if match is, if the length of result that you get here is not 1, that means it's different than 1. So it's a collection with some number of values, not a single value. Then make sure that, result, then make sure that the length of that collection, and you've already converted match to the length of match. That means that they are equal. And if it not, complain, and then return res. So that's again a bunch of words, but let's see what it means. So for example, and this is an important difference. So if you listify high, you'll get the string high within the list like this. If on the other hand, if you just did a list of high, you'll get H and I as individual characters within a list. That's not what happens when you listify a string. When you listify a string, what he expects you to want as a result is the string stuck into a list, not the characters in the string separated into individual elements, made into a list. Listify array 1, again, same thing. Array 1 goes into a list. If this were a multiple entry array, and we spent some time discussing it last week, if you recall, then a list of that would actually unwrap the elements of the array, and you'll get each element inside the list. But that's not what a listify does. When you, even if you were to listify a 2-element array, you'll still get a single array inside a single 2-element array inside a list. So test equal listify 1 is just 1. If you get a list of 1, 2, then it'll be 1, 2. If you listify range of 3, you get 0, 1, 2. None is blank. Listify 1, 2 of a tuple will be a list of 1, 2. Any questions?
Yeah. So if you take a first example of high, if I say high, let's say Sunday. So if you have 2 words, what's the listify is going to give us? Is it going to have a 2? Is it just a 1?
So do you want this?
Yeah. Hi there. Yeah. So what's the listify is going to give us?
What do you think it'll do?
I'm not sure. Like, okay, so
based on this,
it's going to be just
based on this code, what do you think it'll do?
I think it's going to be high there is going to be in a single list. So
Correct.
It's not two words. It's just a one word.
Correct.
One
it's just a string.
Just string.
It's just a string. Yeah. It's a string stuck in there. Now, what I wanted to show you was you do this. I'll do high. Well, doesn't really matter. I'll do this. It'll just be a lot longer. See the difference?
Yeah, that's correct. So the only thing is how I can create the listify where I can have a high as in a one first element and a there as in a second element.
Okay. What do you think would be, based on looking at the code, what do you think would be, how do you think we could do that?
So you probably high and a comma there,
Yep.
then high and a there need to be separated out.
Yep.
Yeah.
You can give this as a tuple or you can give this as a list. It doesn't matter.
Yeah.
Right. And in fact, that's where I was also saying that, you know, if you did this and we looked at it, but it's worth looking at, you know, doing these things helps to solidify our memory as well. So if I do you have to give an array? Oh, you give it that way. Okay. Array open. I think, well, let me try this. Well, do I do that? Or do I just do, okay. Let me do a 2-element array like that. I think I have one too many of these, don't I? No, I do need another one. Okay. Oops, didn't like that. Okay, I think I need to give it a single, it's a 2-element array, which is that. Oops, not that. Come on, there. Okay. See, it gave a single array of 2 elements. Did you see that? Now,
Yeah.
sorry, are you guys still there?
Yeah.
Okay.
So we gave a array of 1 and 2, but it didn't split the array. It's just kept the
Exactly.
array intact.
It kept the single 2-element array, right? Now, on the other hand, when I say unwrap, see what happens when I do this. This actually has 2 elements in it. It's unwrapped the elements of the array.
Yeah. And
Okay.
That's
the difference that I was rambling about earlier. That's the, I mean, here he doesn't illustrate that, but this illustrates that.
So in this case, it's unwrapped and give us the value within the list. But the case above on cell number 100, it's just taken an array and then
stuck it into a list.
Yeah. So
see, it did this. It executed this line of code. See, in this case, what does it say? If it's a string or it's an array, just stick the object into the list.
Oh, okay. Yeah. So it didn't unwrap and just as is. The definition got listed as is.
Yep.
Okay.
The object got listed.
Yeah. Okay. And so what's the usage in this case?
That's, I think, I mean, you know, he says that, and I do believe this. You know, when you start coding in deep learning and stuff, generically you want the usage to be more of, don't unwrap, I just want the array in a list. I don't want the elements of the array to be unwrapped and stuck in a list. More often than not, you want this result in data science than you want this result.
Is that the processing done at the time of like when you execute a code? So are we
When you're creating data, when you're building data pipelines and things like that, more often than not, you build up an array and you say, okay, let me just store it in something like an array. Now, don't know, Dinesh, whether you were part of the class when we looked at the transform list, for example, which is, like you apply the transforms and then you stick it into a list. So that's the TFMD list of FastAI. And there, for example, after the transform, you just want those arrays. You have all those arrays like tensor arrays. You just want them in a list. You don't want them suddenly again unwrapped into individual tensors when it's being put into a list.
Yeah, okay, makes sense. Yeah,
right? After you have gone through the trouble of transforming blah 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 and building up an array, now I want it in a TFMD list. I do a list of something and then it just unwraps the thing. That's not what I want. I want the array to be maintained as an array and just stuck into a list.
Yeah.
Which is what Listify does, but that's not what list does.
Yeah, makes sense. Okay, thanks.
And you could argue which way. I had gotten so used to seeing a string stuck in a list that after spending so much time on FastAI, I was like, oh shoot, list actually splits it into characters, but that's the default usage in Python, right? Python doesn't stick. When you do a list of high, as we saw, it doesn't stick high into a list. It splits this into characters and sticks them in a list. Okay, moving on. Here is the array. I just was wanting to show that if you print the array, you get this, and you print listify of the array, the whole array is treated as a single element in a list. So this is, for example, what I was referring to, right? Like if you have an m by n array of tensors that you have built up, and you then say, instead of listify, list, and it splits it up, then that's most than likely in data science not what you want. So that's kind of what why he has the listify code. And this is just an example that, again, I already printed and took you through earlier. A listify array will still give you a single array, whereas if you try that with a list, it will split it into its elements. The other thing that it does, listify, is it makes a list. This is something, by the way, a list does as well. So if you list a generator, it will return the values in the, it will stick the values, it will evaluate the generator completely and then stick the values in a list. So you need to be careful, because if this is an infinite generator type of thing, or then you can literally run out of memory if you did this. It's the same for a list too. So listing generators, you have to be careful. And this is where the match code comes into play. So look at what happens here. The object we are sending is of length 1. We say match is 3. Here we're directly specifying an integer of 3. So it takes that object and then broadcasts it, which means it makes that, puts it into a list, and then makes it uh, duplicates it until its length matches the length that you've specified. That's why you get the value 1 stuck 3 times in a list. Right? Now, look at what happens if you specify a range of 3 instead of exactly the int 3. It takes the length of this guy, which is 3, and does the same thing as before. If instead, just to keep it, just to illustrate, if I make this 10, then you'll get a list of 10 ones. Oops, since it's checking, I don't want to type 10 ones. Let me just make 5. And that should work. Okay, now if the listified item is not of length 1, it has a length, then the length should match. Otherwise, it will complain. So the first one, the length matches, so it works and it returns a list with 3 1 values. If on the other hand, this guy, which is the object you're sending it, its length is 2, you're telling it to match 3, or if you gave it a match of range 3 here, in either case, you expect a failure because the length of this doesn't match the length of this, which means when you go to the listify code, this assertion will fire saying match length mismatch, and because when that fires, then it will say test fail will pass, because that means that you've gotten an error. So this guy fails when these links do not match. Okay, and then tuplify is exactly like listify, just make over tuple. So in fact, he is cheated by just saying return a tuple of listify, everything else being the same. So instead of a list, he makes a list and then converts it to a tuple. So simple enough. And now, since this is kind of a miscellaneous stuff and basics, he defines true of x to be a boolean of, now here is an interesting twist to it. If x is true, it will return true, which is what this accepting does. But since again it's a data science oriented library that he's building, he first checks for a, and most things in data science are collection of elements, and so he checks for a length, and if the length is non-zero, boolean of a non-zero value is always 1, so it will return that. But what if the object has no definition of length? Any collection object should have a length definition, but there could be objects which don't have a length definition. If an array and stuff will have a length definition, but actually, as we'll see in a minute, an array doesn't, but a tensor and stuff. But again, there's a way to check. Here, he just says check whether the object's length exists and return the Boolean value of that. And if that fails, which is what the exception clause is, then just return the Boolean value of that x itself. So that's how he defines truthiness of an object x. Now let's look at what, therefore, when we run the tests, what those tests look like, because there's an interesting case here. So he's just saying print the object, print the true of the object for the object in, and then he gives a bunch of values. So let's keep the first two. Actually, we'll come to the first two, discuss more of it. But this array has a length of 1, right? So because this array is given, so it's a non-zero length. So it will say Boolean of a non-zero length, so it will be true. So for array 0, which is this guy, it will return true. This guy will have a length of 2, so obviously it's non-zero, it will return true. Now keep in mind that even though the value is 0, the length returned by array of array which has a 0 value will be 1. So that's not 0. So that's why you'll get a true value here, a true value here. It's 1. It'll not have a length, so it will get out of here, it will come here, boolean of 1 is true, because any non-zero boolean is true, so it will return true. So 1 is true, 0 for exactly the opposite of the reason I said. Whenever that's a 0 or a none or an empty string, it will return false. So that's why these three are false. But now let's return to the interesting two cases, array and I give it a 0, or array and I give it a 1. In one case, it returns false. In the other case, it returns true. That was very puzzling to me as to why it does, why it returns false for this case and returns true for this case. So see how that happens is because in when you send in an array 0 into the true, then the length check fails for both array 0 and array 1. Okay, that means it tries to execute this guy and it fails. An exception is created because array of 0 doesn't have a length, array of 1 doesn't have a length. It will
What does
have a length only
does
when it's stuck into this. Sorry,
yeah, so
question?
what does the array of the braces 0 means then, or array of braces 1 means, like not the square brackets but the first
Yeah, it just means the value 0, because here's what is happening. That's a good question. So because see what happens is it fails here, but it comes here, right?
Yeah.
When there is an exception, it will go to this line of code. So when it executes this line of code, bool of the array of 0, its value is 0. So bool of x, when x is a 0 valued object, will return false. That's why this guy returns false. But when bool of array of 1 will return some other non-zero value, because I could have stuck in a bool of, I could have stuck in an array of 100. Any non-zero value that x has, array of x, it will return true.
So array, so the going back to my question, so array of 0 means the value 0. We're talking
That's
about
what I think.
constant
Yeah.
0.
Yeah.
And then array of 1 is the constant 1, like or as you said 100 would be the constant.
It'll be 100.
Okay. Then it makes sense. Yeah. And another question I have is, so if I go to the try, so let's say array of a 0 and a try, and we say the return boolean of length, obviously length of a constant is not going to be evaluated, but wouldn't it return a 0 or like?
No, length is not even defined in that case.
Okay, so that's gonna be
it
like
fails.
an error.
Yeah.
Okay.
Therefore goes to except. There's an exception.
Okay.
It has an exception. I ran it, which is what, and we can run it right now too. Let's do it. Let's see what. Okay, let's just do this. Actually, why am I even doing that?
Yeah. This. That's going to be error. Yeah.
Right now, see the value inside it doesn't matter.
Okay. Yeah.
Right?
Yeah.
Because it's an unsized object. Now, but when I do bool of this, which is what that guy is, right? The value matters because it is boolean of a non-zero or boolean of a 0. That's why you get the difference. You see that?
Yeah. 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 Boolean of length of x and a boolean of x, there is a difference. Yeah. Yes.
Right.
Yeah.
And x value matters because x, as long as it's non-zero, will return true. But if it is 0, it will return false.
Correct. Yeah.
right? So that took me a little, that's why I printed this and I added this to say, hey, this is what is going on. Because I was like, why in one case am I getting a 0 and in another case I'm getting, or false and in another case I'm getting true? I had similar questions to what you have, like, what is that? Okay, and then you get into even more interesting. Now these are, now I can understand this part where he does the stuff, but this is even more interesting, and I'll, maybe I'll sync up with Rekil to see whether he can find interesting cases where this is used. I do know he uses this because I recall him, or I recall seeing code which uses it, but I don't recall where. So, which is, he defines a null type, okay, and returns null, meaning, he returns null when you get an attribute, or when you call this type, or when you index into it, and then you return false in when you evaluate the Boolean value of a null type. Okay, so that's kind of what, I forgot to run this. That's what this null type does. Oops. Okay. Now see what he's doing here is he's saying Boolean of null dot high dot there. I mean, in fact, I don't know why he does the dot there 3 blah blah blah, but as long as you use null is an instance of null type, and you do a Boolean on null dot high, and you actually, when you do a null dot high, you're doing a call on a null, which means you go there, which returns a null, and then you do a Boolean of a null, which returns false. That's why you get false.
So the null dot high. So you said, how come the high is going to go into a call?
Because that's how, I mean, that is the definition of a method call, right? I mean, you just call the here. So for example, you have a null, or null is a null, this class.
Yeah.
And when you define, anything, you call it, and you're passing in high, but as a, any kind of, and remember again, arguments. So if you pass in, you're getting an attribute, any kind of attributes. So this is again a method call dot high, and between a call and getting an attribute, you're just going to get nulls in either case, and that null is passed to bool, and the Boolean value of a null type is false, right? So I mean, it doesn't, actually, I think even if you were to do any other thingy, null dot there should be, it doesn't matter what method you call, I would imagine.
Yeah, since get attribute is returning null.
Yeah,
Anything.
because the get attra of any kind of arguments that you're giving it, it returns the same type object. And then you go and call that, which is a method call, which is these brackets, and that returns a null. And then you go into that and you get a bool, because remember again, just like repr, when you do bool of any class, it will call the dunder bool, and then that returns false. So eventually, after going through all these loop-de-loops, it just returns false.
Okay, so let me get it right. So when we say, when I wrote a null, so when I write null dot this as a function, so first of all, it's going to call the get attribute, get attra. So, and then afterwards, the second method, it's going to automatically call the call, dunder call. That's what you're saying. And that's pretty much it. And then afterwards.
No. I don't think so. It's a call the bool. That's the second, because this is a method on its own. Methods don't call on dunder call. It's just the class that calls dunder call.
Sorry, I didn't get it.
Like the only thing that I think can call dunder call is null. So if you're like calling null itself, like putting a bracket for null, then you'll be
Yeah,
calling
so,
just like forward in PyTorch.
Yeah, so I might have explained the reverse order. So he's saying null is a call to the thing, and then an attribute get is the get atra, and either way you get nulls. And then when you do a boolean of a null object which is null type, then you get the dunder bool and it returns false.
Yeah, so I got the bull I got it. However, the sequence of these dunder get atra and dunder call, that confused me. I understand the return null of both these functions as well. However, how does they get called? That's the confusion I have. Get atra and dunder call.
Well, if I may add, in this case, we're not really implementing dunder call. We're just using get atra. So when you call null, like null.high, the first thing that gets called is get atra. Then the dots there, get atra still gets called. Then when you index into it, get item gets called. Then you now have bool, so dunder bool. I don't know if that makes sense. Like, is it? Do you still have questions?
Yeah, so bool part is fine. The only thing, only confusion I have is, we are doing a null dot high or null dot this or null dot there. So I am assuming when we do dot high, actually instead of that function, it's getting called the get atra and dunder call. Maybe I'm wrong. So that's the confusion I have. What's the sequence of those function get fired?
Yeah, I like to run it, in debug mode or something to see, and I'll do that offline, Dinesh, to, or you can try it yourself. But there are, I forget now what it's called, but there is a website that you can just stick this piece of code in and then chase its execution sequence line by line, and it will tell you in what sequence these things are called. So you can stick this definition, this guy, and then this line of code, and then it cause it to execute. I forget the site that allows you to do that, but if you did that, then your question would be answered. I am not 100% sure, so I don't want to say something that I'm
okay.
wrong.
No worries. Like I'll test it. Yeah, let's see.
But you can see, for example, in this case, it's just doing null dot high and not even calling the function. It's just the attribute. So here it just gets the attribute, boolean, boom, false. Right? Whereas here it's a method call. Right? And he's saying, look, I can call it, I can chain it because he's chaining it here. And I can index it because he's indexing it here. So this indexing will go to call get item. I originally thought that something like high call would end up with call. I could be wrong. And of course, the attribute is just, any attribute you call it, it's returning null. So any of these three things return null. So it returns this. And then Boolean of that is false. So any any which way you go, you end up with false.
False. Thanks.
Which is the purpose, right? Because an object that's false and that can be called chained indexed. And that means you want an object which is false, which can be called. That's why you can call it and it will return false. You can chain it like he does here, and you can index it as he does there. Right? And then he has another convenience function, to null, which again converts and return null which is, if it's a none type, then if X is none, returns null, otherwise X. Again, that's why I'll sync up with Raquel to see whether we can find usages of these. I mean, it's not complicated code, but the more interesting thing is where does he use it and how does it help? Understanding it is easy, but where it's used and why is it useful is more interesting. So Boolean of to null, none. So because it's none, it'll obviously return null. And then you do a high and you do a there, obviously it's a false because the null object is of none type, which is false. Okay, now we get to kind of the interesting, or at least one of the interesting things that he, or interesting function that he sets up, which is more complicated than others and is, I think, pretty neat. So what he is defining here is code called get class, and it's very cool because, by the way, I don't know how many of you are familiar with a data class object or a data class in Python that was introduced much more recently. That is analogous, I would say, to what he is defining here, because data class again helps you to define a class very quickly without a lot of additional syntactical sugar, or or I should say more details of syntax. So you can do, and maybe next time I'll take you through an example of a data class definition and how that's done. The data class has a few more bells and whistles, which are slightly different, enables you to do a few more things than his get class does. But on the other hand, get class has a kind of couple of cool features that I don't think data classes have. But anyway, let's look at get class code. So here, get class, and then you give it a name of the class. You supply it a bunch of names of attributes, but positional ones. The soup is actually super classes. That's why he calls it super. But in Pythonese language, Python typically calls these as base classes. That is the classes from which this class inherits stuff. And this is the documentation. You can specify functions that you want to be modules in the class, and the fields are keywords that you supply instead of positional arguments. So these are more dict-like structures which have a key and a value. So let's go through the details, and I'm going to kind of be a little bit brief here because it's better understood by usage than just by staring at the code. But I'll take you through it really quick. Dynamically create a class, optionally inheriting from SOAP, which is why I said these are base classes or super classes, and containing field names. Okay, so it defines attributes as a dict. So a key is a name in the attribute dict and used for positional attributes passed in field names. And these are positional. The attributes are positional. So they don't have values. You're actually sending in the position, the values themselves, right? Whereas here you're saying key equals value. Here, since they are positional, you're actually sending in the values. Then for each of these things in field names, attributes of F, just make them none as the default. And then because, this is actual value. So the attributes of F, which means the values, will be none. The keys will be the actual values. And again, it may seem like I'm rambling, but you'll understand it better when we look at an example. For funcs, key is the name of the func, and the value is the func itself. So in this case, you listify whatever you specify to funcs, and then you add to the attributes dictionary. The name of the func is the key, and the function itself as the value. And then obviously, because this is a dict, you just say key value in the items, you add the keys as the keys of the attributes, and you add the values as their values. Once you've done all that, you say if there is no superclasses, make it an empty tuple. If, on the other hand, superclass is not a tuple, then make it a tuple. And then he's defined an init, and similar to the fields case above, positional keys. So here he just enumerates these, adds as attributes the keys at these indices, and then sticks in the values v. And then for kv, obviously keyword adds, so it's a lot simpler. Key values from the items, stick them in as keys and values, and then combine into all fields all of the field names and the keys from the fields dot keys. So you just in the attribute value, by once you're done here, you've captured all of them, and then this is just a dunder equal, meaning equate all of them, and then build a wrapper if you don't have super classes, and then add an attribute in it to be the init for this particular init attribute, or dunder init is actually the underscore init, dunder equal is underscore equal, dunder wrapper is the basic wrapper. And then finally, after doing all that, you just return type of name, and then these are the superclasses, and then with all of the attributes that you wanted to build into the class. And then obviously you stick in the documentation and then return the rest, which is the class that you want to build. But that's a lot of words. Let's look at its use in practice, and we can go back as appropriate to see how it's used. So underscore t, you say get class, the name of the class, attribute a. Now that's why I was saying this is a positional, I mean a string, and then a keyword. So an a attribute with no value and a b attribute with a value of 2. Then you define an instance of that class. So now you see what the code above has done is it has created the class and underscore t. Obviously an instance of underscore t is t. T dot a is none. That's, it's a positional thing. It's a attribute a with no value. That's why you get a none and t dot a. But t dot b has a value, which is 2. So when you do test equals, then you say t dot a none, t dot b 2. Now, the interesting way that he has handled, and I talked to you about the position, or I was rambling, and you can go back and look at the code. You can pass in, instead of doing like, or you can pass into underscore t, instead of empty brackets, you can just say 1. So guess what? Now this is a will get the value 1. And then you can say b equals 3, which means t dot b will become 3. So you check that. Test equal t dot a is 1, t dot b is 3. And then you can passing in as positional values. So t is underscore t 1 3, which means it'll say, oh, 1 is a, so it'll become a is 1, and the next guy is positionally 3, or the positionally b, and b is the key and value is 3, so it'll become 3. And then he's just checking that wrapper of t. Remember, he made it equal to the basic wrapper, and basic wrapper we went through the code before. That's why you see underscore t, a equals 1, b equals 3. And then he's checking that you can actually dump it. You can use pickle is what he's checking, and the way he typically checks it is he dumps it and loads it and checks that it's equal to the original value. So you dump t, you load t, and you check that it's t.
Sorry, just a wrapper of t. You said basic. So here we are not calling that basic wrapper.
Just yeah, he is. Remember why? Because see, remember this is t is underscore t, and underscore t has been defined as get class blah blah blah, right?
Yeah.
So look at get class code wrapper. attributes of wrapper, which means to this class is sticking in dunder wrapper as basic wrapper of all fields.
All fields. Okay. Okay, makes sense. Yeah.
Right. So
Yeah.
that's why you get that.
Yeah. Thanks.
Okay, and then
yeah,
sorry, go ahead.
But is there like a place where he shows an example? Why does he need it done that equal to? Is it like I can't see any test for it? Is there like any place? Because in the definition of get class, there's a done that EQ. So
yeah, dunder EQ, right? Yeah,
yeah,
I
why?
have not looked into why he defines a dunder equal to be an equal. But what I, what does it return all of the attributes of, and then he says def equals self b, all get attribute self k, get attribute b of k for k, not b. I Here's my guess, and we can see whether in usage he uses this anywhere. But my guess is by doing this, he's making sure that if you're comparing, see, he has built into see, in Python, in order for two classes to be compared, you have to define the equals in the class object, right? And if you have defined two classes using make class, this would make it, this is my guess, I may be wrong, is it ensures that you get the attributes for all of the object B, let's say, which is a different class built with make class, and the current class, and ensure that all attributes for K in all fields are exactly the same. That's how you make sure that the classes are the same.
Oh, okay. I see that now. Cool.
You see what
Thanks.
I'm saying?
Yeah, I see it now. I understand.
But where he uses it, I'll have to talk to Rekul to see whether he can dig it up. Okay, where were we? Make class. So, obviously what he did is define get class, right? So far. But the additional thing he says most often you want to use make class, which ends up adding the class to your module. A module is just a set of functions or classes that you define in Python, right? And when you define a class, you want the class to be added to the module, and make class does that. So if you see, you have all of these the same things, except you have added mod. And all it does, if mod is none, it tries to get it itself. So it just says sys.getFrame1.f.local. So it just tries to say, hey, locally, can you give me the name of the frame from sys, and blast, stick it in mod. And then it just calls that with all the rest of the fields. And then it says, I'm going to make a class with the name nm, which is this guy, and make that an attribute of mod. You see that? So he's just creating the class with get class, sticking it in the module. So he's just adding the class to the module. That's all he's doing additional. And then he has this additional line of code which helps you to find the name of the module if you don't specify it. If you specify it, then you're good. It uses it. And then mod name equals rest just makes the, because mod is, or a module is just again like a dict. So mod of something. So mod name mean mod class becomes the class. So the class in that module is res. Okay, so that's kind of what he's doing there, and very often you'll just use that. So Now, if you run this notebook by yourself, one of the strange thing is, yes, that you'll find, and it will run for me now because I was working on this notebook prior to the class starting. But if you run it just by yourself and you run it the first time, it'll give you an error. And that's because for some strange reason, he moved the get attra definition and code from the foundations notebook to the basics notebook. He got rid of it from foundations, which is the prior notebook that we were looking at, which is where, I mean, because my copy is dated, which is where it still sits. But getAtra is defined further down in this notebook. So when you get an error, if you are running this notebook, remember to go down in the notebook where getAtra is, run those 2 cells, and then come back and execute it, and you're fine. I don't know why he didn't take those 2 and stick it above where he uses it. But anyway, just FYI. So it will run without error for me now because of the fact that I've gone ahead and run getAtra where it's defined in this notebook further down below. But forget about that. Bottom line, what he's saying is you can directly inherit from here, and that should work. And it will say is instance of T getAtra, and it ought to obviously pass because you're saying that class T, you're inheriting from getAtra. This is the traditional way of doing it, right? This is how you would normally run it with inheritance, but you can do it using make class. So make class underscore P A equals 1, and you can say sup, which is the superclass, is getAtra. And you define an instance, you check the attribute is 1, and you again assert P is an instance of getAtra, and it will successfully pass. Is that clear, or any questions about that?
So what's
Oh, sorry.
it's clear. So but why we are doing the make class then?
Oh, the make class is not for this. Even get class, if you supply sup equal getAtra, it will still work. He just says that typically we just use make class because get class is because you want to add the class to a module. You never typically want to define a class and then leave it hanging, meaning it's not part of any module. So invariably you'll use make class. Now that's just a generic thing to say. That said, you can, he's just pointing out that when you use make class, you can pass in a super class like getAtra and make sure that the class you create is an instance of getAtra. That is, getAtra has now become a superclass of P.
That's
That clear,
correct.
or is that still confusing?
No, that's correct. But I'm like that the same we are achieving the same behavior by the cell above, where you're saying like the traditional
Yeah,
way.
the make class doesn't. So that's why I was trying to say make class doesn't change. He could have used this example with just get class itself, but make class adds the class to the module. And he's just saying generally you will always use make class. So he's now, after this cell, he switches to using make class. That's all. There are
Okay.
2 orthogonal, he just introduced the make class concept here. After that, he's going to use make class. Then he says, oh, one of the things I forgot to tell you was, you can specify a super class, and then any instance of this class that you're making will be an instance of its superclass.
Okay. So
Okay,
he'll be
so
using
he's
all
making
the.
2 orthogonal points. One is not necessarily linked to the other.
Okay.
Right? And then you define a dict and you say this is a dict, then it'll still show up as an instance of dict. Okay, and then this is the thing that I was also rambling on about. A dunder init is provided that sets the attribute for any keyword args and for any args matching by position to fields, along with a wrapper which prints all the attributes. The doc string is set to doc, and you can pass funcs which will be added as attributes with the function names. You saw all this code as I was rambling through the code up above, and you can go back and look at it. But bottom line, see, here's what he does. Let's say you define a function foo and its job is to return 1. You say make class t a, I want a superclass as a dict, my doc is test doc, and my funcs is foo. Then what happens? I define an instance of t. I say I underscore t. Remember here he's just specifying positional. So 3 is a, b is 2, is changing the value of b to be 2. T dot a is therefore 3. T dot b is therefore 2. Then test equal t dot foo, and he has added the funcs to be foo, and so you get 1, and you check t dot dunder doc is test doc and t is dict. Okay, now let's see, and then he defines a decorator which makes the function a method of the new class, passing the parameters to make class. So actually, instead of going through this code, it's easier to look at this usage and then go back. So a decorator, he defines at wrap class. So you can do an at wrap class. This is underscore t is the name that you want to pass to it. And then a is 2, right? And it's a decorator, so you have to decorate the function. The function is decorating is this def bar self x return x plus 1. So what does that do? It actually calls make class, sticks this function into the class with name, and then it returns this inner def inner. So bottom line, when all said and done, you're creating or building a class, and this instance of the class will now have AS2, and it will add this function as a method to the class underscore t, which is the nm here that you have passed in. And if you pass in, because the method says x, so you're passing in x, it says return x plus 1, which means 4. So now this function is added as a method under this 2, I should say. This function is a method added to the underscore t class, which has another attribute a equals 2. So here's the t is underscore t, test equals t dot a is 2. And interesting thing is, the class instance t has a bar method to which you can pass x, which is 3, and it will return x plus 1, which is 4.
It's kind of similar to patch, but this time we're creating a class.
Yeah, but this is to the class.
Yeah.
Right? And patch, yeah, actually, it's a good question of how it's different, but patch, monkey patch changes the, here you're defining it, there you
Defining the class on the fly.
replace something which is in the original and override it.
Yeah.
With a patch. And a patch 2, if you recall, actually patch 2 does that. And a patch, and I always again get confused which is which, but one of them matches the type and the other doesn't.
I can't remember.
Yeah, which is which, but one of them, patch 2 and patch, and patch is, but anyway, so that's what the wrap class does. Okay. The next two cells aren't that great, so aren't that important. It's just saying ignore exceptions, then exceptions will be ignored because he's defining this as a what is that, as a config manager. And then execute local, he's just saying execute the local code, blah blah blah. And then he just says check execute code A1. And then he talks about this curried instance, and by curried he just means that you can do it in steps one after the other, which will be more relevant when we look at further down the ops part. And that's what these two cells do. So these four, I have not seen too many use cases or examples, but this curry thing is interesting because we will see that a little further down as we go through the rest of the code um, as well. Um, so all he does here is, if this object is none, you're returning a partial where you're just going to do an R instance on types, and otherwise you do is instance object types. And so, for example, what you can see here when he does that code is R instance, R is instance, then it says int1. That means, is one an int, because that's what you're doing, is instance object types. Assert not is R is instance string 0, because 0 is obviously not a string. If you had stuck a string, then you wouldn't have the not. Assert R is instance, and this is the example of what he talks about as currying, which is R is instance int. So you can just supply the types, and it doesn't have an object, and see what happens when it doesn't have an object. That means it says if object is none, I'm going to return a partial of R is instance types, and the types is int here. So what you get is R is instance int. So now it knows that that's what it has. Then you again send it one, and it will say, oh, I now have to check whether one is an int, and it will still say that's true. So which is why it will not flag any assertion errors. And you'll see that a lot more in use and better understanding of it as we get into ops manipulation that he does below. Much like the null, none type, and also I think the true, he also defines noop, and noops. And noop is just, it does nothing. So basically noop of x equals, and then passing args and keyword args do nothing. So noop says test noop 1 is 1, test noop 100 will be 100. It basically does nothing. It returns whatever you send it. So that's what noop does. And then what is noops? Noops is noop, but with as a method. So you just say do nothing, but as a method. So in the class, you say foo is noops, and then you test underscore t dot foo, and then you pass it a 1 or 100 or whatever, blah, blah, blah. You'll get the same value return. So that's all noop and noops does. The only difference is noop is just a function. This is, you add it as a method that you add to a class. Okay, I think in the interest of time and having everybody break before people who join the hands-on machine learning, we'll start with infinite lists next time. This is a fairly cool capability that actually I do remember he uses it in multiple places in FastAI code. And we'll get into that next time. We'll start here and go through the rest of this notebook, and if we get done, then we have at least two more notebooks in fastcore itself. One is underscore or something extra and then there is a bunch of meta classes and a bunch of other decorators that he has stuck into. I think it's called meta something. So those are two more notebooks after we are done with this one that we'll go through on Passport, but we'll start at infinite list the next time around. Any questions before we are done for this one? So next week, Rakhil will go through as many examples as he can find of usage of L, usage of methods of L, as well as anything up to this point, any usage of make class and other things that he finds in FastAI. That's what we'll start with. And if he's done, then we'll start with infinite list and go forward from there.
Sorry, please. I haven't been around. Have we touched the meta classes? The meta
No, not yet. That I'll go to that after I cover extra, and that's we have touched meta class once when we did the, if you recall, Tendo, when we did, I forget now what it was. I think it was the actual type definition.
That was what we're looking at FastAI itself.
Yeah, but he defines a bunch of other meta classes that he uses, and it'd be useful because we don't use meta classes. I myself forget how it works or what are the, so we'll go back through the relevant part once more at the very end,
no problem.
after we are done.
Yeah, no problem. No worries. Thank you.
Yeah. Okay, cool. Thanks for joining, and I'll see you all same time next week.
Okay, thanks so much, Srinivas.
Thanks.
Bye.